Okay, 4.2, isosceles and equilateral triangles. These are objects that you have had earlier in your math career, your educational career. They have told you about these two things. So we will be reviewing what they are, not learning what they are. Does that make sense? Okay, so an isosceles triangle, remember, has two sides of equal length, yes? Okay, it has one line of symmetry, such as an eye. So an isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are, guess what? Congruent. What does it mean? We say objects are congruent, but their measures are what? Equal. Correct. Okay? So the angles and sides are objects, so we say they're congruent, but when I start throwing in the numbers, then those are equal. Yes? So let's look at our picture. It says if side AB is congruent to BC, and I do have that on there, right? You see the marks? Then angle BAC is congruent to angle BCA. So these are opposite, yes? Could that come in handy once in a while, probably? Yep. Also need to review with you, what do all the angles in a triangle add up to be? 180 degrees. So the converse, that means I undo it, right? I do it in backwards. I do it backwards. So the converse of the isosceles triangle theorem says if two angles of a triangle are congruent, then the sides what? Can we fill in the rest? The sides what? Opposite. Those angles are what? Congruent. Kyan, can you please put your phone? Quit messing with it. Okay, so my picture says that angle ACB and BAC are congruent, yes? So my theorem tells me that those sides opposite are what? Also congruent? So that could be helpful, couldn't it? Yes. So now we're going to use it. You ready? Everyone? Okay, so we have this nice triangle, and I know this angle is 28 on the left, and I know that we have two sides are congruent. Yep. And we're going to do what is the value of x and, oops, skipped on me, and the angles. We're going to find the angles too. Because once we find x, can we find the angles? Yes. Yeah. Okay, so what do we know? What did we just learn?
The right part of the triangle is 28.
Right. We just learned that when we have two congruent sides, the opposite angles are equal, right? They're congruent. So if the left is 28, the right is 28. Yeah? Okay. So what else do we know about triangles? 180. They all add up to 180, right? So let's make ourselves an algebraic equation. So what equals 180?
5x plus 9 plus 28.
5x plus 9 plus 28 plus 28. So I combine all my like terms, right? So 28 plus 28 is 56 plus 9 is
65.
65. You guys agree with him?
Yeah.
Okay, then now, I wrote an algebra problem, I just have to solve it, right? So how do I solve this algebra problem?
Minus 65 and 180.
Minus 65. I get 115. How about you?
Yeah.
And then what?
Divide by 5.
Divide by 5.
That would be 25.
And that would be 23.
22.
3.
Okay? Now, x isn't, it isn't a degree, is it? It's just part of one. So I know the two angles are 28. How am I going to find this third one then?
5 times 23 plus 9.
I'm going to take 5 times x, which is 23, plus 9. So 5 times 3 is 15. Carry a 1 is 115.
Yeah.
Yep. Plus 9 is 124. Now, Kyan said, well, couldn't we have just taken 180 minus 56? Could we have? Yep. And gotten what? 124. But do we also need to remember how to do evaluating an algebraic equation? Yes. So, again, I said this to the last class and they didn't know what it mean. They ever heard the expression more than one way to skin a cat? No one ever heard that before? Brian, you have?
Why would you want to skin a cat?
You wouldn't want to skin a cat. Is there more than one way to do the problem? Yes. Okay, so next one. It's a little bit different, isn't it?
Yes.
So it tells me that two sides are congruent, yeah?
The two bottom two angles are
So the bottom two angles are congruent. So what does that mean about those two expressions there?
That they're equal.
That they're equal. So how are we going to solve them?
So you're gonna add those two. And
No, you're not going to add them. You just said they're what?
Oh, they're equal.
Equal, so you're going to do what?
So it says we're taking it.
I feel like we already did this.
Did we already solve triangles? Yes. Okay, this is nothing new. I'm just telling you now we have an isosceles triangle, right? Okay, so you guys do that, and I'll do it. We better get the same answer, right?
Yes. Nope.
Quirt. You got my lady.
You get that, Henry? How'd you do it?
Add 4,
So you added 4,
and then add 3.
That was too easy.
and so you get 12 equals 12x.
Whoops.
Did you add wrong?
Yes.
Okay. And then we divide by 12, yes? And x equals what?
1.
1. So if x equals 1, now I need to find all that stuff. Did he not get 1? Did he get 1?
No, he's tipping.
Oh.
It was.
Okay, so what do? I plug in 1, yes?
Yes.
So 4 times 1 is -4, right? So -4 and 9 is 5. So this whole angle is 5 degrees. That's pretty little, isn't it? Okay, so when we do the next one, we better get what? 5 degrees. So we get 8 times 1 is 8. Minus 3 is what? 5. So if I know the two bottom angles are 5, how are we going to find the top one?
Subtract by 180.
180 minus them added together, which is 10, so that angle is 170. Have we done a lot of this stuff before? Yes.
Yeah.
The only difference is I've told you that we're using an isosceles triangle. You've done that before. You just didn't know you were doing it. Did you? Okay. Ready for next two? Okay. Ooh, a fraction.
Oh, my friend.
Okay, these are sides.
They annoy me.
I don't have the luxury of making sides equal to 180, do I? But I do know that angle P and angle Q are congruent. How do I know that, Lyndon?
Well,
How do I know that angle P and Q are congruent?
there's it's 180.
Cooper?
They have the little circles.
Yeah, they have the little arc, right? So that tells me they're congruent. So if I know that angle P and Q are congruent, what do I know about PR and QR? They're congruent. So, I touched it. So it tells me these two are congruent. So congruent means the numbers are what?
Equal.
Equal. So I set x plus 20
20.
equal to what?
8 over 3. 8x over 3.
8x over 3. Now I'm going to get rid of my extra. So I got to solve this problem. So the first thing I have to do is move the 3 out of the denominator.
I should do the 120.
So I have to, well, I could subtract 1 from 8/3. You guys want to subtract 1 from 8/3? I want to move the 3. How do I get rid of the 3?
Reciprocal.
Reciprocal. So times 3 on both sides, yes? So on the right, the 3's reduce, and I get 8x. And we're not really getting rid of it. We're just moving it to the other side, aren't we?
Yeah.
And what does the 3 outside that parentheses tell me I have to do with the 3? You have to multiply, but there's 2 things, so it starts with a D. Distribute. So multiplying is distributing, right? So I get what?
3x plus 60.
3x plus 60. Then I
The,
Subtract three.
minus
Subtract
3
3.
to 8.
Yeah.
and so 60 equals 5x.
Yup.
And then
Divide by 5, so it's 12.
divide by 5, so x equals
12.
12. So now we need to find what x is, and we also need what to find and lengths. Okay, so I have to plug the x back in, right? So this would be 12 plus 20 equals
20 or 32.
32. So the other side better also equal 32, yes? So I got 8/3 times 12. And that 12 is over 1. The 12's in the numerator, yes? Does 3 go into 12?
No, yes. But
How many times?
4.
4. So the 3 becomes a 1 and the 12 becomes a 4. And what is 8 times 4? 32. Is that what it was supposed to equal?
Yes.
Yes.
You take 180 minus 60.
No, you do not. Not for sides. Not for sides. Okay, so we plug in 12. So I have 6 times 12 minus 12. So what's 6 times 12?
72.
72. Life is much easier when we know our multiplication facts, correct?
Sure.
Minus 12 is 60. Okay. There's one missing thing on this triangle, and that would be what? Angle R, yes? Could we find angle R?
If you really want.
No, we can't. Why not?
So we don't know.
Because we don't know what these angles are either, do we?
Nope.
So if we had one of those angles, could we find the rest? Any one of those angles, could we find the rest?
Yes.
Yeah. Okay, so the next one, what are we going to do?
Take
2R.
8x minus 1 equal to 4x plus 5.
Okay. So you guys do it. Get me an X.
Too hard.
I'm not going to get a whole number, am I?
Nope.
I'm so mean.
I'm done.
Can I leave it 6/4?
It goes
No. What goes into 6 and 4?
2.
2. So it reduces to what?
32.
3 over 2. Okay. So I got 3 over 2 now, right? And now I got to plug it into all those, don't I? So I'm going to have 8 times 3 over 2 minus 1. And 4 times 3 over 2 plus 5. I usually write them all out before I start working them, just because I feel like I'm accomplishing something. And the last one is what?
2 over 3.
2 times.
3 over 2 plus 7.
Okay. So, guys, 2 goes into all those numbers, doesn't it? Does 2 go into 4? Or 2 go into 8? 4 times, right? And what's 4 times 3?
12.
12 minus 1 is
11.
11. So the other side better come out to be what also?
11.
11. Okay. Does 2 go into 4? How many times? 2. So 2 times 3 is
6.
6 plus 5 is 11. Ooh, look at that.
What?
Okay, how am I going to do this one? This one's even easier, isn't it? 2 goes into 2 how many times? 1. And 1 times 3 is 3, and 3 plus 11 is
14.
14.
That's too much.
You multiplied 3 times 11. Add.
Oh.
Okay,
She doesn't know. I'm gonna use this one.
so we are, my plan this year, and I think you guys have seen it, am I pushing a lot of algebra solving equations like every day? Yes? Have you noticed that you guys are getting better at solving those equations? You're getting quicker at it? I have noticed it. And that is the reason I'm doing it. Because I want next year when you go into Algebra 2 that's pretty well like we got that down. I don't have to teach that anymore. Right? Okay, ready for the next portion? Okay. Isosceles triangle bisector theorem. Okay, isosceles triangle is a triangle that has 2 equal sides. Yes? What does a bisector do?
Bisects it
Bisects it in what?
half.
Half. 2 equal pieces, yes? Okay, so it says, if a line or line segment bisects, is that blue okay to see? Everyone see that blue okay? Okay, bisects the vertex. Now the vertex is the top angle that's not equal to the other two. Okay, that's called the vertex of an isosceles triangle. Get that? Everyone get that? Like, here's an isosceles triangle. These angles are equal. This angle right here is the vertex angle. Make sense?
Okay.
It has
Not
to,
equal.
yeah, because it's the vertex angle. No matter where it's at, it's the one that's not equal to the other two. Okay? So, the vertex angle of an isosceles triangle, then it is also the perpendicular. What's perpendicular mean?
Plus sign.
Perpendicular, it means they meet at a 90-degree angle. Yes. Perpendicular bisector of the opposite side. Now, I have 2 pictures, and all the rest of them we wrote on the one picture. I don't know why I put 2 pictures here. So let's look at this. We're going to look at the left-hand picture, this one right here. Got me? Okay, so I have an isosceles triangle because it tells me right here, correct? Yes? Okay, it tells me that this segment bisects B. How do I know that? Because of the curves on both sides, yes? So if it bisects B, then I know where it touches down here is a what? Right angle?
Yeah.
And then that also tells me that AD is congruent to DC. And that's what the picture on the right is. Make sense? Could that be pretty helpful? Yeah. Because before I could make AB equal BC and solve it, right? But with that extra line, could I make AD equal to DC and solve that as well? Yeah.
Too many letters.
Too many letters.
Yeah.
I talk too fast, and so my letters want to go blah, blah, blah. You guys done? Good? Let's use it. Okay. So what is the measure of RSQ and the length of PR? Okay, so we're going to do some stuff. What do we know about this triangle? It's an isosceles, yes?
Yeah.
How do we know that?
The 2 lines.
It has 2 sides that are equal, yes? So if PS is congruent to SR, what do I know about P and R?
They're
They're congruent also, right? So what's R?
31.
31, okay? So angle R is 31, okay? So if we want to know angle RSQ, so we're going to make a plan, okay? So angle RSQ, well, that's this much of the whole angle S. How much is that of angle S? What portion of it? What fraction of it is it? It's what? It's half. How do you know it's half?
Like the line
How do you get out of that?
split.
Because it's split and it puts the arcs, yes? So if I know angle S, can I just take half of angle S? Okay? I just made a plan of what I need to do, didn't I? Okay? And I'm not going to do it yet. I'm going to go PR, see what I can do there. So if I want PR, how am I going to find PR? I don't want numbers, I want objects. So PR is the whole thing, isn't it? Yeah?
PQ
So PQ
is equal.
plus, no, I don't want that. I want PR. So PQ is plus what?
P or RQ?
QR. Isn't that equal to PR?
Yes.
Yes. Okay, now we're going to start filling things in. I just didn't want to do that yet. Okay, I want to make a plan first. Because our problem's going to get pretty complex and entwined. Yes. So if we make a plan, that helps me out, doesn't it? Okay, so you want to do the angle or the side first?
Side.
Sides are easy, huh? Okay, well, I know QR is 4, don't I? What do I also know PQ is?
4.
How do I know that it's 4?
Because that is a bisection.
Because if this bisects, then it is perpendicular, which means these two segments are congruent. Yes? So 4 plus 4 is what? 8. Well, that was easy. Okay. See if we can make angle RSQ that easy. Well, we know that R is 31 also, right? We already said that? And our plan is to take half of S, so we probably should find S, shouldn't we? Yeah? So how are we going to find S?
31 plus 31 equals like 1.
No.
So-
You give that's 4 2.
So you're going to take 31 plus 31 equals 62. Why are you doing that? You're not wrong, but why are you doing it?
I don't know, I just know it's right.
Then what do we got to do with that, Cooper?
Because wait, they both are 31.
Right. But what's angle S going to do? How are we going to find angle S, guys?
Shouldn't you subtract it by 180
We're going to take 180
minus 60?
minus angle P plus angle, what? R? Isn't that what we're going to do?
I know.
Yes.
And what is P plus R?
62.
62. Have we done stuff like this already, guys? Yeah.
That's 118.
118? You guys agree?
Yeah.
I think I do. Okay, so angle S is 118 degrees, so now what do we have to do with it?
Divide by 2.
Divide by 2 or multiply by half. It's the same thing, right? So 2 goes into 11 how many times?
5.
5. Carry a 1. 2 goes into 18. 9. So angle RSQ is 59 degrees. Don't forget your degree symbol. So did we have to find the other stuff to be able to find what they needed? Yeah. You basically had to solve the whole triangle, didn't we? That's okay. Now, could I find this length and this length?
Yes.
Mm-mm. Not with what you know now. You could with the, you could do that with some trig functions and stuff. But what you know now, we don't know anything about it, right? I'd have to know one of the sides or an equation or something, wouldn't I?
Which one?
These RS and PS. We'd need a little bit more information, wouldn't we?
118 minus 180 and then minus 31.
No, those wouldn't give me angle, the side lengths, those are only angle stuff. Okay, last thing we have is an equilateral triangle. What does equa mean? Equal. What does lateral mean?
Straight.
A side. Lateral is a side. Like it's straight, it's a side. So an equilateral triangle is equiangular. Okay, what does that mean?
They're all equal.
What are all equal?
All sides and equal.
Well, all the angles, right? Angular. So if all the sides are equal, then all the what are equal?
Angles.
Angles. So an equilateral triangle is an equal angular triangle. We should put triangle there. and an angular triangle is a what? Equilateral triangle. So does this go both ways? Yes. Okay, so an equal angular triangle is an equilateral triangle. Equilateral triangle is an equal angular triangle. That's all this statement says down here.
They're all equal.
So, if all the sides are equal, then all the what are equal? Angles. Now, I'm going to tell you a secret. What do all the angles in a triangle?
180.
180. And if all three are equal, then what are they?
180.
180.
Well,
No.
all together.
180 divided by 3. 180 divided by 3 is what?
60.
60. 3 goes into 18 6 times, yes? Okay, so every single equal angular triangle, no matter how little or how big, what is every single angle in that triangle equal? 60 degrees. I will never, the book will never, ever tell you again the measure of an angle in an equilateral or equal angular triangle. Why not? Because it's 60. If you forget that, it says equa, so they all have to be equal, yes? All the angles in a triangle equal what? 180. How many angles are in a triangle? 3. So should you know to divide 180 by 3?
Yes.
Yes. And after you do that about 2 times, are you going to remember that it's 60 degrees? Yes. Until the next time you have to do it, and you have to do it all over. Okay. So I have on the left, I have 2 triangles forming a quadrilateral. What's a quadrilateral? Quad means what? 4. 4-sided object, yes? Okay, the triangle on the left is a what kind of a triangle? Equilateral, meaning it's also an equal angular. Okay? What kind of triangle do I have on the right? An isosceles, because it has 2 sides that are congruent, yes? Okay, so it says QBD is 130 degrees. Okay? So that means SBD, this whole thing right here is what? 130 degrees?
Shouldn't it be 100?
Nope. It says 130. That's what it says, right?
Oh.
I said Q.
Okay, that helps.
CBD. Blech. It says it's 130, yes? Okay, and I want to know BAD, bad. Actually, we're going to find all of them just because I want to. But how are we going to find BAD first? We got a lot to do. What do you know? What do we know that this?
Those all 3 equal 90.
No, they do not. They're all what?
30.
No,
60.
they're all 60. How do we know they're all 60?
I'm gonna get that.
180 divided by 3. So you're going to put 60, really small, hopefully neater than me, in here, yes?
Yes.
Okay. Well, I'm going after, to answer this specific question, I'm going after BAD, right? I'm going after this angle right here. Isn't that angle the same as this angle right here? How do I know that? It's an isosceles triangle, right? Okay, well, I know this part's 60. What do I know the other part is then? If I know this is 60 right here, what do I know this part of it is?
70.
How?
Because 60 plus 70 is 130.
So, yeah, or 60, or 130 minus 60 is what? 70. Okay, so my vertex angle of that isosceles triangle is 70. And I know these two are equal. So how am I going to find them?
180 minus 70.
I'm going to take 180 minus 70, because that gives me the remainder, what I have left, right? Which is 110. And I know that A and D are congruent, so they have to share that. So I have to divide it by what? 2. So 2 goes into 11, how much?
5.
5. With 1 left over. And 2 goes into 10, how many times? 5. And so that means that angle BAD, which is congruent to angle BDA, is what? 55 degrees. Make sense?
Yes.
Have we had to find other things before we find what we really need to before? And are you going to continue to do that? Yes. Okay, so now we have this other picture. I'm gonna just put 55 under here so I can erase this extra part so it doesn't get in our way. Cool. Okay, so what do you see on the left? What kind of triangle? STV is what kind of a triangle? It's an isosceles. You caught yourself. You're going to say equilateral, right? But this other side has 2 lines, doesn't it? Yep. So I have a isosceles on the left. What do I have on the right? An isosceles as well, right? So we're going to find all the angles in this one as well. So I know the vertex angle is 72. But I also know that this piece, yes, and this piece are what? They're equal. They're congruent. So I know that angle, I got to name them right, don't I? STV is congruent to angle SVT. And now we got to figure out the measurement, don't I? So how am I going to do that?
Subtract
180 minus 72, which is, I get 108. What do you guys get? 108. Okay. So that means that both these angles add up together to be 108, but they have to be congruent. So I divide it by what? 2. So 54. Okay. So we know they're 54. So I'm going to erase some stuff, and I'm going to write 54 in there. So I know this is 54, yes? And I know this is 54, and not 45.
Wouldn't angle B altogether be 180?
Yeah, this whole thing right here would be 180 because it's a straight, yes? So if the left is 54, how are we going to find the right of it? Okay. So 180 minus 54,
26.
126? Yes?
Yes.
Yeah.
Okay, let me get a different color here. So this is 126 over here, yes? Okay, so I still need to find the 2 other angles, but what do we know about these 2 angles right here? They're congruent, right? So how am I going to find those?
126 minus 180.
And then divide it by 2. So we know that angle VTU is congruent to angle VUT, right? So we're going to have 180 minus 126. That's what you said, right?
Yeah.
So it's 54. And then I have to divide that by 2. So 2 goes into 5 twice. Carry a 1. So 14. So 27.
Yeah.
Okay. So we know those other 2 are 27. So is it going to take a little work? Yep. But can we do it? Yes. Okay. So what I'm going to do is